So last year we learned about this. 2 to the 5th is equal to what? 2 times 2 is 4, times 2 more is 8, 16, 32. So is this bringing back any memories yet? Not yet. This is the base. Logs. This is the power. This is the answer. And then when we write it as a logarithm, it becomes log base 2, 32 equals 5. So logs always have the base, the answer. Yeah, logs BAP. So base, answer, power.
I thought you're saying that 32 is the answer to the log.
Oh. No, so that's the, yeah. So remember, logarithms are really saying 2 to what power is this number? So 2 to what power is 32? So that's really what a logarithm says. And then we have another special case when we have like e to the second. Remember, e is a number. So if I were to go to my calculator and I'd go second ln, that pulls up the e. And e squared is 7.389. So if I had e squared equals 7.389, remember when we write that as a logarithm? Yeah, log base e, we don't ever write logies. We have, instead of log e, we have the logarithm of the natural number.
Oh, isn't the e that you get from the ratio and stuff?
Uh-huh. So ln of 7.389 equals 2. So that's saying e to what power is 7.389? That is 2. So remember, every time you see an ln, there's an understood base e. So ln is an understood base e. Okay, figure this one out. Regardless of what the base is, if that's 1, what is it?
Answer
Is 0. Because anything to the 0 power is 1. So regardless of what the base is, if that's 1, pi to the 0 power equals 1. 357 to the 0 power is 1. So anytime you see a 1 right here in this spot, so anytime you have a 1 as the answer, the power had to have been a 0. So that's kind of a general rule on that. So here's some more things. Let's just talk about this. If I have 7, can I do anything as a power to make 7 become negative? Because what does a negative exponent do? It makes it 1/7, right? 7 to the 0 is just 1. 7 squared is 49. So there is nothing I can do to make my answer be negative if the base is positive. So when I have a logarithm, regardless of what this base is, this part must always come out to be positive. Now the exponent can be negative, because like negative 1 on the exponent is just 1/7. But that answer right there always has to be positive. Okay, so now we're going to really mess things up on you and throw things in here that you've been working with all term. What's something? We'll do that. What is the domain of that problem? What do we know about this stuff under here? Or inside of here, it all must be positive, right? So we're going to go back in time to when we had this problem, like 2 chapters ago or last chapter. I can't remember which one. So it has to be greater than 0. And you solved this as though it were 0. So you factored x minus 6 and x plus 1. And you get that x equals 6 and x equals negative 1. And these are your critical values. And then once we had our critical values with an inequality, we put them on a number line. Is this coming back to your memories? And then we chose test numbers. And on my answer key, I did what I told you not to do. I used my test numbers to create my intervals. Yeah. So we plug negative 2 in. Negative 2 squared is 4. Negative 5 times negative 2 is 10 minus 6. So that number is bigger than 0. So this area worked. I plug 0 in. 0, 0 minus 6 is not greater than 0. So this region didn't work. I plug 6 in. Plug 7 in. 49 minus 35 minus 6. 49 minus 35 minus 6. That combines to be negative 41. So that's 8, which is bigger than 0. So my domain on this problem, negative infinity to negative 1, along with 6 to infinity. So that would be the domain on that problem. Those are the possible numbers that x could be. So on this first one, 7's the base, right? Mm-hmm. Over here we have some question mark, really. So 7 to what power equals my answer, which is 7 to the 5th. So what does my power have to be? Right? 7 to what power equals 7 to the 5th? Well, that has to be 5, right? If I have just plain 7 and it equals 7 to the 5th, this part has to be a 5 in order to make it a true statement. 7 to the 5th equals 7 to the 5th. This ln is the same idea. What's the understood base of an ln? So e to what power equals e to the a plus b? Yeah, so that's a plus b. So here's a general idea. If you ever have a log and the base and this answer base are both the same, it's kind of like they just cancel each other off and the part that's left is the answer. So like if I have log 3 equals 3 to the x minus 4, then it equals x minus 4. It's like the log 3 and the 3 go away. Okay.
What's that number? Like, what's the name for the number? You have the log and the base, and it would be the answer. Do you understand what I'm saying?
No. Okay, so on this bottom one, log 7 of x minus 3 equals 5. Whoops, this was supposed to look like that. Anyways, 7 is the base, right? And then that goes 5 equals x minus 3, correct? So this 7, here's in essence this is how most people teach you how to solve logarithms. They say, oh, put all of this stuff as a power and do it to both sides, and then these go away. And you get the same thing, 7 to the 5th equals x minus 3. So that's how most people teach you to solve these. I tell you just to rewrite it in exponential form. That's how I tell you to do it. I just say write it in exponential form, take the base, take the power, put it equal to the answer. So in this case where 4 is the base and log 4 is the power, it's like these cancel each other off and you're left with a minus c. So that's kind of the general idea with why we even look at those. If I had log 5 of 2x equals some number, again, most places will tell you to solve this by putting a 5 here and a 5 here. And then the 5 log 5 goes away, and you're left with 2x equals 5 cubed.
Wait, so like on the third one, since they're both 4s, is that why they cancel each other off?
Uh-huh.
So they're the same.
Yeah, they have to be the same. In essence, all it really is understanding that this is the base, this is the answer, and this is the power. So you take the base to the power, 5 to the third equals 2x. So that's the justification of how that works. It's just that I never really teach it that way. I teach you just to understand what logarithms mean. But when you get some chemistry teacher, this is what they'll tell you to do. They'll say just put this as a base 4, those cancel off, and that's your answer. But this is the reason why that works. So you're supposed to graph some of these. So you have like y equals log base 3 of 2x, and you're supposed to graph that on your calculator. Well, you're actually supposed to do it by hand. But with these calculators and with Desmos nowadays, you can just graph them on your calculator. So on your calculator, if you hit the math button, so if like go to y equals, then you hit the math button, and if you hit the up arrow, it's faster. You can get to where it says log base. So then I choose enter, and then I can type in whatever I want to. So if that's log 3 2x, I can type a 3 here and a 2x in there. And then you can hit graph, and it'll draw your pretty picture for you. So with the advent of these nice calculators and Desmos Online, logarithms are much easier to graph. So this is your generation, because if this was not taking place 5 years ago or even 10 years ago. So anyways, that's made life much easier for you guys to graph these. So that's all your assignment is doing this kind of stuff. So page 438. Oh, so you all remember, no class tomorrow or Friday. Yay. So I won't see you until after the break for this class. Woo! So page 438. These ones will go by really fast. I hope. 9 through 2? Yeah. It looks like it is a lot of problems. It doesn't just look like it. It is a lot of problems.
Yeah.
But like I said, I really hope I really hope those fly by. Like in my head, this is 10 minutes for those problems. But sometimes my head's way off. These ones you're graphing, so you're just going to draw a picture. We could talk about the asymptotes and stuff on them. We probably should someday. We kind of did. Remember when I said that all those answers have to be positive? Yeah, so that's what that was talking about. That's where the asymptote comes in. It'll start saying these are undefined. Like if you go to your calculator and you hit second graph, it brings up the table and it says all these are errors. That's because you can't have negative numbers in the answer spot. And so that's why those don't work. And so really there's an asymptote at 0, at x equals 0. And then you ought to do a few of these. These ones will take a little bit more time, but not forever long, I hope. Eeny, meeny, miny, and mo. And one of those and one of those. Okay, that'll be all. Except we should use it for a story problem. Do you want decibels or pH?
pH.
Okay, pH it is.